Welcome to The Explainer. Today, we're going full-on cosmic detective. We're investigating a mystery that's been hiding in plain sight, right inside one of the most spectacular objects in our sky. For decades, the Red Spider Nebula has held on to a pretty big secret, but you know what? A flood of new evidence just came in, and it looks like we finally cracked the case. And right here, this is the core of the problem. Look at it. We all learn that stars are basically giant round balls of gas, right? So how does a round star die and create this incredibly intricate, two-lobed, symmetrical shape? It just doesn't add up. Physics tells us a single round star should make a simple round nebula. So what's really going on here? And believe me, the answer isn't just about this one nebula. It could totally change how we think about the final, beautiful moments of most stars, just like our sun.
So, to solve this riddle, we have to start by examining the scene of the crime. The Red Spider is what's known as a planetary nebula. And here's a fun fact, that name is super misleading. It has absolutely nothing to do with planets. At all.
Yeah, a planetary nebula is really a star's grand finale. It's this beautiful, glowing shroud of gas that a star, kind of like our sun, puffs out into space during its final moments. It's the star's last gasp before it collapses down into a white dwarf. But here's the kicker. This whole spectacular light show only lasts for a few tens of thousands of years. On a cosmic timescale, that's barely a blink of an eye. Now, right in the heart of the Red Spider is what's left of that original star, this exposed, super dense core that's on its way to becoming a white dwarf. And it is scorchingly hot. We're talking a surface temperature of about 160,000 Kelvin. To put that in perspective, that's nearly 30 times hotter than the surface of our own sun. And it's that intense, blistering radiation that's lighting up all the surrounding gas and making it glow so brightly. So, for years, this super hot central star was suspect number one. But astronomers were totally stumped. Why? Because they couldn't get a clear look. There's this thick veil of cosmic dust right at the heart of the nebula, basically hiding all the crucial evidence. It's like trying to solve a mystery with the lights off. You know something's there, but you can't see what's really happening. And this right here shows you what a complete game changer the James Webb Space Telescope is. On the left, you've got Hubble's view, invisible light. The central star looks kind of faint, and the core is almost totally blacked out by that dust. But then, look at the right. That's Webb's view in infrared light. It just punches right through that dusty veil like it's not even there. And bam, suddenly the core is glowing. It's luminous, and we can finally see the engine that's driving this entire incredible structure. Webb's ability to see in infrared isn't just a cool feature, it's its superpower. That's the key that unlocked this entire mystery. It lets us peer right through these massive dust clouds that are completely opaque to other telescopes. It's literally showing us clues that have been totally invisible until now. But here's the thing, Webb didn't crack this case all on its own. It was more like the lead detective who called in a whole team of specialists. You had the Chandra X-ray Observatory looking for high-energy clues, the ALMA telescope mapping out the cold gas, and of course, Hubble providing that classic original view. Putting all their findings together is how we got the full story. Okay, so with this dream team of telescopes on the job, the clues started pouring in. And what's so fascinating is that each new piece of evidence, even though it came from a different instrument looking at a different kind of light, started pointing to the exact same conclusion. All right, clue number one came from that amazing Webb image. Webb saw a ton of infrared light coming from the core. But here's the twist. That glow wasn't coming from the star itself. Nope, it was the heat signature of something else right next to the star, getting absolutely cooked. And that something else? It turned out to be a compact disk of super hot dust heated to about 1,000 Kelvin. Now, a single lonely star just shouldn't have a structure like this. A hot, compact disk spinning around the center is basically a smoking gun. It's powerful, powerful evidence that you don't have one star at the center, you have two. So clue number two comes from these spider legs themselves. Turns out, these aren't just pretty wisps of gas. They are massive lobes, each one about 3 light-years long. And they've been inflated, almost like balloons, by incredibly fast and powerful outflows blasting out from the very center. And when I say fast, it's just mind-boggling. We're talking about jets of material firing into space at 300 to 400 kilometers per second. That's over 1 million kilometers an hour. And once again, a single dying star just doesn't have a way to create such focused, powerful, high-speed jets. It just doesn't work. But it gets even better. By tracing the shockwaves these jets created in the gas, Webb found something really specific, a distinct S shape. Now, to an astronomer, that is a classic telltale sign. It screams that the jet isn't firing in a straight line, it's wobbling or precessing. And that kind of wobble is almost always caused by the gravitational tug of a second star in the system. The final piece of the puzzle came from the ALMA telescope. It found a ring, or a torus, of really cold and really dense gas wrapped around the nebula's waist, kind of like a belt. And this dense ring is expanding slowly, completely differently from those super-fast jets shooting out the top and bottom. So the question is, how could one star possibly produce two totally different kinds of outflows at the exact same time? A slow, dense one and a fast, focused one. And this table just lays it all out perfectly. This is the power of that multi-telescope approach. When you put all the evidence together, the case becomes undeniable. JWST saw the hot disk and the S-shaped jets, pointing to two stars. ALMA found the dense ring at the waist, also a sign of two stars interacting. And get this, even what Chandra didn't see was a clue. The lack of X-rays told scientists how dense the material was. Every single piece just fits together perfectly. So, let's connect the dots. The hot disk, the fast, wobbling jets, the slow, dense ring. All of this evidence reveals the secret that the red spider has been hiding. It was never one star. It's two. There's a hidden companion star locked in a gravitational dance, and that chaotic dance is what sculpted this entire cosmic masterpiece. So we know what happened. A second star was the culprit. But how? Well, there's a theory that explains this whole dramatic scene perfectly. It's called common envelope evolution, and it describes a violent, chaotic, but ultimately creative dance between two stars. It unfolds in this incredible four-step process. First, engulfment. The bigger star expands into a red giant and literally swallows its smaller companion. Then, ejection. As that smaller star spirals around inside the giant, the friction rips the giant's outer layers away and boom, that forms the dense, slow-moving ring we saw. Third, accretion. The little companion star actually survives this whole ordeal and starts pulling material from the giant's now exposed core into a swirling disk around itself. And finally, inflation. That disk becomes a cosmic engine, launching those powerful high-speed jets that inflate the giant lobes, the spider's legs. And there you have it. The mystery is solved. The incredible, mind-bendingly complex shape of the Red Spider Nebula wasn't made by a single star acting alone. It's the product of a dramatic, violent, and ultimately creative partnership, a cosmic struggle between two stars that left behind this breathtakingly beautiful work of art. So this particular case might be closed, but you know what? It opens up a much bigger and way more fascinating question. The fact is, the vast majority of planetary nebulae aren't simple spheres. So if these hidden stellar partnerships are the key, then just how many of the universe's most beautiful and complex structures were also born from the chaotic dance of two secret stars? It really makes you wonder. It seems the cosmos is just full of secret partnerships.
If you're ready to explore the hidden truths behind mysterious sciences, subscribe now and become part of the enlightened society.